Hey everyone, Mr. Voikin here. We're going to take a look at the third system for converting units in this unit, which is called unit analysis. And this is the one you're going to be using a lot in your science classes to convert between units. So it's a good one to make sure that you understand, because it's not only going to help you in this class, but it's also going to help you in your science classes. So when we were doing proportional reasoning, remember we were looking at two equal fractions. So what was on the top was equal to what was on the bottom. But with the unit analysis, we're doing it a little bit differently. Instead of making two equivalent fractions, we're multiplying one fraction by another fraction, and we're using information that's on the top, so in the numerators, to cancel out things that are in the denominators. So just a little bit of review on multiplying fractions to begin with. So if I have 7 over 11 and I multiply that by 33 over 7, we could just multiply this all the way through 7 times 33 and get the number up into this position, and we can go 11 times 7 and put the number here. But we always need to sort of put it in simplest terms, and it's way easier to do it in this state right here rather than waiting till we get to the end right here. So if we notice right here, we got a 7 on the top and we got a 7 on the bottom, and even though they're in different fractions, I can cancel these out. So basically 7 divides into 7 one time, and 7 divides into 7 one time there. Okay, now if I look here, I got a number 33 up top and a number 11. They have a common factor, which is 11, so I can divide 11 into 11 one time and 11 into 33 three times, and now I end up with 1 times 3, which is 3, and 1 times 1, which is 1, and 3 divided by 1 is going to equal 3. Okay, so if you understand that, then that will really help us when we're trying to use the unit analysis to do something like this, which is convert 150 kilometers per hour into a certain number of meters per second. Okay, so we don't have, if we make two fractions, I've got 150 kilometers per hour, and that would be 1 hour, and I'm trying to get to meters per second, so I can't really just say they're equal to here, because it's just not going to be able to work. I don't have any values to put in these positions to do some cross multiplication. So what am I going to do instead? I'm going to multiply this number by another fraction, just like I showed you just a couple seconds ago. Now, what am I trying to end up with? Well, I'm trying to end up with meters up top and seconds on the bottom, which means I need to get rid of the hours. I need to convert that into seconds. I need to get rid of the kilometers and convert that into meters. So remember, top and bottom, if they're the same, they cancel each other out. Just like I had the 7 and the 7 up top, they cancel each other out and become 1, which is essentially we just sort of ignore. So what am I going to do? Well, I'm going to, up top, I'm going to put hours. Okay, and why am I doing that? Because hours will cancel hours. And what am I trying to go to? Well, I want to end up with seconds on the bottom, so I'm going to put it on the bottom. And now I'm going to just basically say, well, how many seconds are in an hour? There are 3,600 seconds in 1 hour. And I know that because there are 60 minutes in an hour and 60 seconds in a minute, and 60 times 60 is 3,600. Now, if I multiply this through, we're going to end up with 150 times 1, which is 150, and the units that are up top are still kilometers. And on the bottom, I would multiply this through and get, 1 times 3,600, which is 3,600, and the answer is seconds. Okay, now we're not quite to where we want to get to. We're trying to get right here, which is meters per second. So I need this kilometers to be gone. So basically, what am I going to do? The same thing. I'm going to multiply it by something. This time I'm trying to get rid of kilometers. So I need 1 on the top and I need 1 on the bottom. Why? So they will cancel each other out. Okay, what am I trying to go to? I'm trying to go to meters. So what do I know? Well, I know that 1 kilometer is 1,000 meters. And now if I take what I have here, I've got 150 times 1,000, which is going to be 150,000, and the units that I have up top are meters, and that's what I'm trying to get to. So successful there. And on the bottom I have 3,600, and the units that are remaining there are seconds because the kilometers got canceled here. So successful there. I am now in meters per second. The only thing is that I would want to now divide 150,000 by 3,600. And when we punch that into the calculator, we're going to end up with 41.66 repeating, and the units are going to be meters per second. And if I was again told where to round that, then I would do so to meet the requirements. Now in this case I sort of did it one time right here, and then I did it a second time right here, but we can just chain this thing along. I don't have to do that one calculation first before moving on to the second one. So let's do this one like we would normally do it, which is 75 meters per hour. And again, that would be a 1 on the bottom. So it's like something is moving at 75 meters every 1 hour. And now we're asking, well, how many millimeters will that same object be moving per minute? So it's the same, exact same value, exact same speed or velocity, but we're dealing with different units. So what am I going to do? I'm going to multiply this by, well, you just got to figure out which one do you want to change first, the distance or the time. So let's deal with the distance. Now, right now, the distance is on top is at meters. So where am I going to put the meters? On the bottom. And what am I trying to get to? Millimeters. Well, let's just say I don't know how many millimeters are in a meter. I could even say go to centimeters. So if I knew that there were 100 centimeters in 1 meter, I could take an extra step if necessary. What's going to happen? Well, meters are going to cancel meters, and I'm left with centimeters up top. Now, that's not where I want to be. I want to be at millimeters. So again, I could do another one, put the centimeters on the bottom. Why? So I can cancel them out. What am I trying to get to? Millimeters. And what do I know? I know that 1 centimeter is equal to 10 millimeters. Now, I didn't need to do that in 2 steps, but I can. Okay, if I know how many millimeters are in a meter, I would just multiply it by meters on the bottom again, so they cancel, and I would be putting the millimeters up top, and 1 meter is 1,000 millimeters. Okay, so I've successfully canceled the meters, and I'm now in the distance units that I want to be in. So now let's deal with the time. So I'm going to multiply by something. Notice that time, the units are hours. They're on the bottom. So what am I going to do? Well, I'm going to put them on the top. What am I trying to get to? I'm trying to get to minutes. What do I know? I know that 1 hour is 60 minutes. And what's going to cancel? My hours. Perfect. That is leaving me with the units that I want. Millimeters up top and minutes on the bottom. So now I just need to multiply this through. So I'm going to go 75 times 1,000 times 1, which I don't really need to do, divided by 1, which I don't need to do, divided by 1 again, which I don't need to do, and divided by 60. So notice that I just strung it along. So I basically went like this: 75 times 1000 times 1 divided by 1 divided by 1 divided by 60. And that will give you the same result. So if I was to now divide this through, I get 83.33 repeating. Now if I was to push this through on the top, I would have 75, 1, 2, 3, and on the bottom I would have 60. And when I take 75 and divide it by 60, we end up with a different number. Well, I've obviously done something wrong somewhere. When I punch this one through on the top, I'm getting an answer of 1,250. So either that one's wrong or this one right here is wrong. So I'm just going to punch this back in my calculator again. So 75 times 1,000. I don't have to do that because it doesn't change anything. And divide that by 60. And yep, that one was wrong. Don't know what I did there. That equals 1,250. Now, what are the units? The units are millimeters per minute, which is what we were trying to get to. Okay, let's move to the next one, number 3. And now it's the same thing. We're just trying to go from millimeters per second to kilometers per hour, except that we're starting off with scientific notation, but not a big deal at all. So let's punch this into the or let's lay this out. So 3.8 times 10 to the 10, and what is it? Millimeters per, and below I'm going to have per second, which is per 1 second. What am I trying to get to? Kilometers per hour. So let's deal with the distance first. So I'm going to multiply that by a number with millimeters on the bottom, and I'll just take that to meters to begin with. So I know that 1 meter is 1,000 millimeters, very common ratio that everybody should know. And that's going to cancel out my millimeters, but I'm trying to get to kilometers, so I'm going to do it one more time. I'm going to multiply it by a number with meters on the bottom. Why? So the meters cancel right here, and whatever I'm trying to get to, which is millimeters, will be up top. And I know that there are 1,000 millimeters in a meter. And now I am at my correct units that I'm trying to, well, that's wrong. Basically what I did is just put ourselves right back to where we started. So let's grab our fancy little eraser tool and do that again. So what should we be multiplying by? Well, we're trying to get to kilometers. So what I need to do is put meters on the bottom, put kilometers up top, and what do I know? 1 kilometer is 1,000 meters, and that will cancel my meters. Looks better. Okay, now let's deal with the time. We're trying to get from seconds to hours, and as we did earlier, we remember that because I have seconds on the bottom, it now needs to go on the top. We're trying to get to hours. That's going to cancel my seconds. And what do I know? I know that 1 hour is 3,600 seconds. So basically, to multiply this out, I want to go 3.8 times 10 to the 10 times the 3,600 on the top, and divided by 1,000 divided by 1,000, and that will give us our final answer. Okay, so I've pulled up a calculator that I've downloaded. It's an app called Calc84, and it's exactly like the TI-84. Well, not exactly like, but pretty close, if not exact. I haven't gone through it enough, but it's slightly different in some of the windows and whatnot. But getting to understand how to use this calculator and having this calculator is going to be a game changer for you. So essentially what I need to do is multiply this out. Now I don't want to change this to 3, 8, and 9 zeros after it and then start punching all that in. I'm definitely going to make some mistakes, and an answer like this is, because it started in scientific notation, is probably going to have to be put back into scientific notation when you're expressing your answer. So I'm just going to show you how, if you have the TI-84, how you would punch that in. So it's 3.8 times 10 to the 10. So you don't actually go 3.8 times 10 and then do like an exponent like that. That's not how we're going to lay that out. Although you can see it sort of works right there. There are other buttons that are meant to do this. So we're going to go 3.8, and it's this double E right here. And you can see it's green, so I have to put a second, and it just puts one E up top. And then I'm going to put the number, which is 10. I'm going to multiply that by 3,600. And then I'm going to divide that by 1,000 and divide it again by 1,000. Oop, one too many. How do I go back and just delete? Okay, and hit enter, and that's our answer. So now let's just say we want this in scientific notation. Well, and it says to express it with just one decimal place or whatever. We can even set our decimal places. So you can do that just by using the procedure to convert a large number to scientific notation. Or on your calculator, you can go to mode, and there will be a section right at the top that's going to ask you, well, what way do you want to express your answer? So right now I'm on normal mode, and if I want to go to scientific mode, I'm just going to turn on that function right there. And you can see that I can even set the precision to how many decimal places that I want. So this answer will express it out to 3 decimal places like that. So if I set that, go back to here and close, and then just hit enter, you can see that it puts it into that format right there, 1.368 times 10 to the 8. So it converts this number into scientific notation for me. If the question was indicating that you need to express it with only 1 decimal place, again, I would just go back into my mode, and I would change that precision to 1 decimal place, and again go back into here and close and hit enter, and it's going to round it up and express it with only that 1 decimal place. So if I was expressing this with 1 decimal place, my answer would be 1.4 times 10 to the times 10 to the 8. And what are the units? Well, kilometers per hour. Slide that to my other screen so I can use it. Make this larger. Okay, so hopefully you have a TI-84 or one of the Casio versions or whatever calculator you have. You just need to learn how to use it properly. So this app right here, this Calc84 app, actually I might as well show you right now. There's, oh crap, that's gone. Don't know how to get that back. There is another one right here that matches up to the Casio, and it's called NCalc, and that's this one right here. So I've got the NCalc and I've got the Calc84s, and they're both free downloads. There is a pro version which I've paid to get, just opens and unlocks a few of the other functions. I don't think it was that expensive. I think it was lifetime membership or whatever they call it, subscription, was something like $7 or $8. Anyways, I'm just gonna shut the video down for a second to go get my screen back. For some reason, when I press escape, it makes it disappear, and I don't know where it goes to. All right, I'm back. There we go. Screen's back up and operational. So let's move down to this screen right here. So this is just showing us that, when we're going to SI units, or there are multiple steps that need to be done, unit analysis is the best thing to use. So definitely going between SI and imperial, you're not going to be able to use a number line. And proportional reasoning probably won't work as well. So the unit analysis is definitely one that you want to understand. Now this chart right here is just giving us some standard conversions. Now over on the side, you can see that it says 1 yard is 0.9144 meters. Now that is a number that has been rounded to 4 decimal places. It's not exact, but it's good enough for most calculations. Okay, so if we're doing any type of calculations, you are going to be given that that chart right there. You're not going to be expected to memorize any of that. Okay, so let's start doing a couple questions right here. So it says convert 760 yards to inches. Okay, so what you need to do is we need to look at the chart, and you can see that we're going from yards. So where do we have yards? Well, right there. Now, where else do I have yards? I got yards over here. Where else do I have yards? Right there. That is it. Are any of them converting from yards to inches? And the answer is no. The closest one that we have is yards to feet. But then we can go feet to inches. So basically, it's going to end up being 2 steps. So let's take a look at this one. Come on. So we're going to be going from 760 yards. Okay, and now remember, this is technically a fraction. Every whole number is a fraction. You just put it over 1. And there are no units on the bottom to cancel. We don't generally write that down there, but we're going to do the same thing. We're going to multiply it by something, and again, because this was a fraction, yards is on the top, which means I need to put yards on the bottom down here. And what did I know? I only knew how to get to feet using the chart that was supplied. So according to the chart, it says that 1 yard is equal to 3 feet. Then I will multiply that by another one. I've already canceled the yards, leaving me with feet, but it's not my final destination there, so I want to put feet on the bottom. That will cancel the feet, and I can go to inches, and I can see by the chart that 1 foot is equal to 12 inches. And now basically I'm just going to multiply that straight through. I don't need to divide by anything, because all of the numbers that are in the denominator are just 1, and dividing by 1 is not going to change anything. So 760 times 3 times 12 equals 27,360 inches. Okay, let's go to the next one, which is kilometers to feet. So now we're going between metric and imperial, and all I need to do is go over to my chart and say, well, how am I going to get from kilometers to feet? So here's kilometers right here. Okay, and there are no other ones. What's that going to take me to? So it's going to be able to get me to miles, but I'm not trying to get to miles. I'm trying to get to feet. So now feet and miles are both in the imperial system. So I'll come back to this side, and I can see that if I know miles, I can get to feet right there. So I'm going to go from kilometers to miles, then miles to feet. So kilometers first, to miles second, and miles to feet finally. Okay, so let's just lay this out. and it's going to be 500 kilometers times, well, what do I want? I want kilometers on the bottom, and like I said, we're going to miles. What does it say? It tells me that 1 mile is 1.609 kilometers. That allows me to cancel the kilometers, and now I need to go over to the imperial side of that chart, and again I will multiply this by, well, I want miles on the bottom. Why? So that these two cancel, and I'm trying to get to my designated units of feet, and according to the chart it says that 1 mile is equal to 5,280 feet. So all the units have canceled, and I'm left with the units that I want right there. So now I just need to multiply this through. So 500 times 1, which I don't do, so it's basically 500 times 5280 and divided by 1.609, and we end up with 164,077.0, and the answer would be feet. Now, that is if we're rounding it to the nearest foot. However, there are actually some decimal places in here, so if I wanted it to be a little bit more precise, then those would be indicated. So again, you would be required to round that to whatever level of precision that the question is requiring. Okay, none of these questions have said where to round it to, so that's not a problem at this point. So let's take a look at this one. We got 4.6 times 10 to the 15 inches, and we're going to meters. So again, we're back into a very large number. So we're using scientific notation, and we have 4.6 times 10 to the 15 inches. And what am I trying to get to? Meters. Well, I can multiply by, I need inches on the bottom, and I know that I can go to centimeters, that 1 inch is 2.54 centimeters. Then I need to go to meters next, so I'm going to multiply it by, some technical difficulties there. I'm going to multiply by another fraction right here. Now, what did I cancel already? Inches. So what am I trying to cancel out? Centimeters. And what am I trying to go to? Meters. So centimeters needs to be on the bottom, meters needs to be on the top. The centimeters cancel, and I know that 1 meter is 100 centimeters. So basically I need to now punch this into my calculator. So I'm just going to bring this up for you here. So we'll pop that back over, and we'll punch in exactly what we see there, which is 4.6 second function EE, and it's to a 15, and I'm going to multiply that by 2.54, and I'm going to divide that by 100. Okay, and when we hit enter, you can see our answer is 1.2 times 10. 1.2 times 10 to the 14, and our units would be meters. Now that is because I've set the precision to 1 decimal place. So remember, you may have to go back into here and set that decimal place to whatever, again, the question is expressing that you need to present that in. So if I just hit enter, it's going to give me a new answer, which is 1.1684 times 10 to the 14 meters. So that's just a little bit more precise, and later on we'll be discussing significant figures and how to calculate how many decimal places we will use in our answer. Okay, so let me just look through here. Whoa. Jeez. Technical difficulties again. Okay, well, I got 3 questions left. So I'm going to not do this one for you because you should be able to do it yourself, but I'll pause the video and then show you the answer. Then I'll do one of the word problems and again pause the video and then just show the answer for that one. And we'll be back in a second. Well, I'm back, and so there is the answer to question number 4, 6.9187 times 10 to the 3 centimeters. So like I said, let's work on question number 5 here. It's just a word problem, but basically the same thing. And then you can do number 6 on your own. So let's see what we got. We got John. It says he ran 10 kilometers in 55 minutes. And what does it say? Jane ran 6.5 miles in the same amount of time, in 55 minutes. So because the time is the same, 55 minutes and 55 minutes, really I can sort of ignore that. So basically I just need to see, well, what is further, 10 kilometers or 6.5 miles? Okay, so what am I going to do? I'm going to just convert one of those over. So I can either take 6.5 miles and convert it to kilometers and see which one is more, 10 or that conversion, or I can convert kilometers to miles and then check that out. So I'm gonna convert the kilometers to miles. So 10 kilometers times how many kilometers and miles in that ratio right there. And I know that 1 mile is equal to 1.609 kilometers. So that's going to cancel out my units again, and I'm going to be left with a very simple calculation, which is just going to be 10 divided by 1.609. And we end up with 10 kilometers is equivalent to 6.2150 and a whole bunch of other numbers. So when I compare them, which one is greater, 6.5 or 6.2? Well, 6.5 is greater. So who ran further is what the question is asking, and you would say Jane ran further. Okay, so you can do question number 6 on your own, and then you can come back to the video. I'll pause it again, quickly do the work, and you can check your workout and compare it to my answer. Okay, so there's the work right here. So we had a cheetah that was going 70 kilometers per hour, and I converted that into miles. So the cheetah is actually going 43.505 miles per hour. A pronghorn antelope is going 42 miles per hour. So the cheetah is faster by 1.505 miles per hour. All right, that is done, and I hope this helps.